All right, we're going to look at inverse functions and how you find the derivative of those. Let f of x be a function and let g of x be the inverse of that function x. So let's go back to what a function does again. If you have some kind of element in your domain here, function f is going to do something to that, bring it over to your range, and you now have that function f at x. If you have a inverse functions will take whatever your y value is and map it right back to where you started. So the inverse function of f should bring us right back to x. What that also means here is if g of x is equal to the inverse, that g should also bring us right back to x. So what that also means then is if we apply the inverse to f of x here, that maps us right back to x, and so that answer should be x here. So g at f of x equals x. Let's remember that here as we move on. So we're going to take that statement out, g at f of x equals x, and we're going to find the derivative of that. The right side's super easy. The derivative of x is just 1, so the right side's easy. The other side, though, we are going to have to do some chain rule here. So remember when you do chain rule, derivative of the outside, which is g, leave the inside alone here, so we're not going to touch f of x, and then times the derivative of that inside function. Well, the derivative of the inside would be f prime at x. Okay, so that statement is should be equivalent then. What we're going to do with that and what's useful then is we know if we divide now that the derivative of f would be equal to 1 over g prime at f of x. And that statement is one, or that process is one we're going to use when trying to find the derivative of an inverse function. Let's take an example of something we know. We're going to let f of x equal e to the x. We've seen that function before. We've worked with it. First thing we're going to try and do is figure out what would the inverse of this be. Well, usually what you've done in previous classes when you want to find an inverse, we know f of x is the same as y, so y equals e to the x. To find the inverse, what we've done is swap those variables and solve for the other one. So we're going to do the same here. We're going to swap the variables, and now we're going to solve for y. To solve that for y, we could natural log both sides. And then what we can do is apply log properties, bring that down, and we know ln of e equals 1, so we end up that natural log of x equals y. That would be our inverse function. And just because we've been using the other ones, I'm going to say then that our inverse function here, I'm going to use g for it. G of x would be equal to natural log of x. That's the inverse that we came up with. Inverse of e to the x is natural log of x. Let's find the derivative of both then. So if we have f of x equals e to the x, that's an easy derivative. Derivative is just e to the x. Let's find the derivative of the other one. We found that inverse g of x is equal to natural log of x. That derivative is not hard either. We've seen from previous videos and from last year that derivative of natural log is 1 over x. Okay, so now let's see. That result we came with from the last one is that derivative of f then should be equal to 1 over g prime of x at f of x. So let's start with the left side. What is f prime of x? We just found that here. That's e to the x. I'm going to substitute that in. On the other side, we got 1 over derivative of g. So I'm seeing here, here's the derivative of g at f of x. So if we're doing derivative of g, that's going to be 1 over whatever is in here, which in this one is f of x. So what's f of x? E to the x. So we would end up with this. Are these two things equivalent? Yeah. If we multiply both top and bottom here by e to the x, we come up that e to the x equals e to the x. So you can see that this derivative thing we came up with for inverses is true. Now let's take that and extend it to a problem you could maybe see on the AP test, something like this. So it says, let f of x equals this that function up there, and let h be the inverse of f. Notice that f at -2 then would be equal to -14. And you can verify that if you want. If you put -2 in for all these x's, this should come out to equal -14. They've probably given us that because it's important to the problem. Here's what they want us to find. What is the derivative of h, the inverse, at -14? Well, from previous problems, we know if we have something here and we use our function, that's going to bring us to f of x. Since h is our inverse here, h then should bring us right back. So what we know is h at f of x should equal x, or the opposite one would be true too. If we applied function f to h of x, that should also bring us back to x. So because they're inverses, they should bring us right back to where we started. So we're going to use one of those to help us out here by applying derivative, because we're going to have to take the derivative if we want to find h prime of x here. I think the one that's going to work the best is that bottom one, because if we apply derivative to that, we should be able to pull h prime of x out of this statement. So let's find derivative of both sides. Derivative of the right side, easy, 1. Derivative of the left side would be using chain rule, derivative of the outside, leave the inside alone, times the derivative of the inside, which would be that h prime of x. And that's what we're after here, h prime of something. Let's solve for that. So that would equal this. All right, and then now where are we trying to find that at? Well, we want to find it at -14. So let's plug -14 in for x here. And that brings us to this statement of f prime at h of 14. All right, so if we can figure out what h of 14 is, then we should be able to hopefully go through and figure out what this equals. How do we figure out what h at 14, oh, sorry, not 14, -14 here. I forgot the negative on this. H at -14, what's that going to equal? Well, that in itself we don't know, but what we have here and what we haven't used yet is, remember this little statement? F at -2 equals -14. We can use that to help us, because remember, if -2 and we apply f maps to -14, what's going to happen if we apply the inverse h to that? H should map us back to -2. So if f at -2 equals -14, then f at -14 here should equal -2. Now, since we know that, we should be able to plug that in for our statement down here, and that gets us a little bit closer. So now we know that this is going to be f prime at -2, because h at 14 equals -2. All right, so now if we just figure out what's the derivative at -2, we got the answer. How do we figure out derivative at -2? I think we can do that up here. We know what function f is. F on the side here, let's find that derivative and then see what it is at -2. So derivative of that, just using our power rules, bring down the 3. So now we got 3 halves x squared. Derivative of the next one would be +3. And derivative of the last one's a constant, that's 0. What's that going to be at -2? I'll plug in -2 and we should be able to find that. -2 squared is 4. 3 times 4 is 12, divided by 2 would be 6. 6 plus 3 is 9. And so that should be 9. Now just take that result, plug it in for here, and we got the final answer. And so it looks like our final answer on this one comes out to equal 1/9. That is an example of an inverse problem you may see on the AP test.